Hello dear students, I welcome you all to the introductory video on exercise 11.9. So in this particular exercise, we are going to learn two very important things. So one is called distance of a point from a line. For example, there is a line given to you, okay, and the equation of the line is ax plus by plus c equals to 0. So this is given to you, all right, and there is one more point given to you, that is x1 y1, okay, and x1 y1 is written out here. Now if you want to find the distance of this line from this line and this point, okay, so we are talking about perpendicular distance, remember, okay. So the perpendicular distance, so this means this distance has to be perpendicular. If I represent this as small d, then this small d is calculated using this formula. Okay, so how to arrive at this formula? So if you want to know more, then you can go to my description. There I'll give you the link for that particular video where I'll show you how to arrive at this particular formula. Okay, fine. Now similarly, the distance between two parallel lines. Now in parallel lines, we know that slopes are equal, right? And we know that parallel line, okay, so for a given line ax plus by plus c equals to 0, line parallel to it will be of the form ax plus by c. This part will be same, so that's why I have written same out here, okay, and instead of lambda I have written c dash here, okay. So we have c dash equals to 0. So these two are parallel lines, as you can see here, okay, and the perpendicular distance between them, that is this line, is given by this particular formula, okay. So again the proof of this will be given in the same video, okay. So you may pause the video and note down the formula. Okay, let's begin with the first question for the day, that is exercise 11.9. I am taking from question number 1. There are 4 sub questions. I'll take 2, okay, 2 problems from that particular number, that is I'll take question number 3 and I'll take question number 4. Okay, so question number 3 says the given point is minus, okay, so question number 1, 3, okay, so point is P, that is minus 1 comma 1, yes, okay, and line, what is the line? Line given here is 12x plus 6 equals to 5 into y minus 2. Okay, so this is my first problem. I want to tell you that your equation of line has to be in which form? It has to be in general form. So that means you must have 0 in the right hand side. So that's why I'll take this everything out here. So before that, we'll just open up the bracket. So we have 12x plus 12 into 6 is 72, 5 into y is 5y, minus 5 into 10 is 5 into 2 is 10, right? So get everything out here. So you'll get 12x minus 5y, 72, this comes over there plus, and it becomes 82 equals to 0. Okay, so this is my equation in general form. So therefore perpendicular distance is given by this particular formula. Yes, so we have modulus of a is 12 x1, that is this one, yes. So x1 is given to be how much? It is given to be minus 1, okay, plus by. So plus b is how much? Minus 5. So that's why it becomes minus 5 itself, right? Okay, so we have y1, and how much is y1? y1 is equals to 1. So we have into 1. Hope you are understanding. 12 x1, okay, so that is a x1 plus b y1 plus c is there, right? And how much is c? C is 82 out here, all right, whole divided by square root of a square. How much is a? A is 12 square plus b is how much? B is minus 5, so minus 5 square. Now quickly evaluate this. So we have this minus 12, this minus 5 plus 82 whole divided by, so this is square root of 12 square is 144 plus 5 square is 25, yes. Okay, so we have 82 minus 12 is 70, 70 minus 5 is 65, yes. So altogether this is 65, it is positive, so no need to put modulus sign now. Okay, so we have how much? 65, and this is square root of 169, no. So what is square root of 169? It is 13. Yes, so 65 by 13 is how much? It is 5. So that's why the perpendicular distance turns out to be 5 in this case. So you may pause the video to note down. Okay, so this is my next question. So question number 4 says point is origin and your line is given in this form. Okay, so let's try to keep it in ax plus by plus c equals to 0 form. Okay, so we have from here h into x is hx plus h into h is h square plus k into y is ky plus k into k is k square equals to 0. So we have first is ax, only x term will be kept. So we have x out here. Yes, so after that we have to write a y term, and y term is plus ky, and the remaining things becomes my c, isn't it? So we have h square plus k square. So this is my c for me. So a is h, b is k, and c is h square plus k square. Okay, so therefore perpendicular distance as per the formula is, okay, so first there has to be modulus sign. Okay, so we have ax1. So how much is a? A is h. x1 is how much? It is 0. Yes, plus by1. b is k, y1 is 0. Yes, into c, plus c is how much? It is h square plus k square. Alright, whole divided by square root of a square plus b square, and a is h square, b is k, so b square is k square. So how much is this? h into 0 is 0, k into 0 is 0, so 0 plus 0 is 0. So altogether this becomes my h square plus k square only. Yes, okay, so we have the denominator h square plus k square. If you want to rationalize it, that also can be done. So we have h square plus k square out here, so we have square root of h square plus k square. Okay, so we have to see clearly. So we have h square plus k square out here into square root of h square plus k square whole divided by square root of h square plus k square into square root of h square plus k square becomes square root, and square root gets vanished. So we have only h square plus k square left. So this and this gets cancelled. So ultimately what is left? We have h square plus k square. Square root of h square plus k square is the perpendicular distance. So you may pause the video to note down. So we have seen how to find the perpendicular distance of a point from a given line. Now let us go to the second kind of problem, that is the distance between two parallel lines. So let me take question number 3. So in question number 3 I am taking question number 2. Okay, so sub number 2. So the given lines are okay, so these are the given lines, and if you compare here, this much is same out here, isn't it? See here, yes, okay, so you have to make sure that they are same. If they are not same, then we have to make them same. Okay, somehow we have to make them same. So we see that they are same out here. So in such case, okay, so this becomes my C, okay, and this becomes my C dash. Okay, so therefore perpendicular distance is given by C dash. Okay, and how much is C dash? C dash is this one, that is 31 minus C. Yes, so minus C, and how much is C? C is minus 34. Okay, divided by square root. Okay, so square root of a square. Okay, so we have, see here a represents the coordinate of coefficient of x, right? So in both coefficient of x is 15, so it is 15 square plus b square, that is coefficient of b, coefficient of y is 8, so 8 square. Okay, so we have 31 plus this is 34 whole divided by, so square root of 15 square. 15 square is how much? It is 225 plus 8 square is 64. Okay, so let's add them. So this is how much? This turns out to be 65. Okay, whole divided by, so square root of, okay, so this is 982, right? So what is square root of 289? It is 17. All right, so my perpendicular distance between two parallel lines is given by 65 by 17. So you may pause the video to note down. Okay, let's have a look at the fourth one. So in fourth one, the two parallel lines are given to be this much. Okay, and we need to reduce this into general form. So get everything out here. So we have minus 2x plus y minus 4 equals to 0, isn't it? Or you want to make it positive, that's also fine. So we have 6x plus, okay, equals to 3y plus 5. So this was the equation. Okay, so from here we see that this is how much? So this is 2x minus y plus 4 equals to 0. So call this as equation 1. Okay, so next is from here we have 6x minus 3y plus, minus 5 equals to 0, right? But if you see here carefully, we have 2x minus how much? Y, yes, but here we have 6x minus 3y. So in order to make them same, what am I going to do is I am going to divide here this part throughout by 3, because if I divide 6 by 3 then I'll get 2x, and if I divide 3 by 3 then I'll get y. Okay, so dividing both sides by 3, then this becomes, right, so this becomes my 2x minus y minus 5 by 3 equals to 0, and you can call this as equation 2. Okay, so hope this thing is clear. If they are not same, then you have to make it same. You have to see the pattern and you have to do the needful. All right, so we founded our first line, that is this one, where c is 4, and we have founded our second line where c dash is equals to minus 5 by 3. Okay, so you will quickly calculate what is the perpendicular distance. So we have c, okay, so c dash is minus 5 by 3. So minus 5 by 3 minus of c is how much? C is 4 whole divided by a square. A square is square root of 2 square plus b square is minus 1 whole square. Okay, so let us quickly calculate this. So this is minus 12, so minus 12 minus 17 by 3 whole divided by, so this is square root of, this is square root of 5, yes. So this is 4 plus 5, right? So we have, so this negative becomes positive because of this module sign. We have 17 by 3, okay, and this is whole divided by square root of 5, right? So this square root of 5 can be written as, if I write this as into, this divided by as into, then this becomes, this root 5 by 1, so it becomes 1 by root 5. So my answer will be 17 by 3 root 5. So you may pause the video to note down. Okay, let's take second question of question number 4. So question says, if a vertex of a square is at a point 1, minus 1 and one of its side along the line 3x minus 4y minus 17 equals to 0, then find the area of the square. Okay, so basically what is happening is there is a square given to you. Okay, so one of the vertices given to you, and let me take that vertex to be how much? It is 1, minus 1. Okay, so one of the vertices is given to be 1, minus 1, and it is given that one of its sides lie along. So one of its side lie along 3x minus 4y minus 17 equals to 0. Okay, so you need to find the area of this particular square. Now let's try to understand. See here, question says one of the sides. Okay, so only one straight line is given, so it can be anything. So it can be this also, this also, this or this. Okay, so it can be anything, but you have to check. Okay, suppose if I choose this line, suppose if I choose this line, then 1 comma minus 1 lie on this line, isn't it? Yes, so if 1 comma minus 1 lie on this, then this equation must be satisfied. Okay, so let's check whether it lies or not. So let us put the value of x to be 1 and the value of y to be minus 1, and we should get 0. Let's see whether we get 0 or not. So we have 3 into 1 minus 4 into y. Y is minus 1 minus 17. Yes, so this is 3, this is plus 4 minus 17. So is this equals to 0? No, right? So this is minus 10. So that's why this line cannot be this. Hope this thing is clear, because in this line this point is lying. So if this point lies on this line, then this point must satisfy this equation, but it is not being satisfied because I am getting minus 10 out here. Okay, so that's why this is not that particular line. Similarly, this cannot be the line, because in this line again we have got 1 comma minus 1. Yes, so 1 comma minus 1, this does not satisfy because I am getting minus 10. So that's why this also cannot be this particular line. Okay, so now my work is very easy. So you can choose, see, we have got 2 lines left, right? So you can take any of these 2 as this equation. So let me take 3x minus 4y minus 17 equals to 0 to be this particular line. It's not necessary that we have to choose this, we can have this as well. Okay, now if you see here in this line, we don't have this vertex. So that's why if you put the value of x to be 1 and the value of y to be minus 1, definitely this will not get satisfied, because this is not lying in this line, isn't it? Similarly, this point is not lying in this line. Okay, fine. So we have understood this much, right? Now next thing is we have to find the area of this square. Now to find the area of a square, formula is side square, isn't it? That means we need to know what is the length of each side, right? Okay, so if you see here, we know that every angle in a square is 90 degree. Yes. Okay, so basically there's a line given to you. Okay, there's a vertex given to you. So can I find this distance? What kind of distance is this? This is a perpendicular distance of a point from a line. Yes, so we'll be able to find this distance. So this distance gives you length of each side of the square. Okay, so it is given that this is question number 4, 2. Okay, so 4, 2, given one side is given as 3x minus 4y minus 17 equals to 0. Let me call this as 1. Okay, and one vertex is how much? It is 1 comma minus 1. Okay, so clearly we showed that, or you can write as, or let me write clearly only. So we have clearly 1 comma minus 1 do not lie on 1. Why? As we see that 3 into 1 minus 4 into minus 1 minus 17 turns out to be how much? It turns out to be minus 10. No, just now I showed you that this turns out to be minus 10, which is not equals to 0. So therefore perpendicular distance between 1 and 1 comma minus 1 gives the length of each side of the square, right? So gives the each length of each side of the square. So therefore let us calculate what is each side, or you can call this as d. So d is equals to a x1. So how much is a? A is 3. x1 is how much? 1 plus b is how much? B is minus 4. Yes. y1 is how much? It is minus 1 plus c is how much? It is minus 17. Alright, whole divided by square root of a square plus b square. A square is 3 square plus b square is minus 4 square. Okay, so let's quickly calculate this. So this turns out to be 3, this is plus 4, so 3 plus 4, so this is minus 10, so minus 10 whole divided by this is 9 plus 16, 25, square root of 25 is 5. So this turns out to be 10 by 5, which is equals to 2. So each side turns out to be 2. So therefore area turns out to be side square, that is d square. So we have d square is 2 square, which is 4 square units. Okay, so you may pause the video to note down. Now there's one more question based on rectangle, which is there in question number 9. Okay, so I'll just give you the hint. So in that case, if you want to find what is the area of this, then you have to formalize length into breadth. Okay, so in that case, if you see, equation of this is given, equation of this is given. Okay, so one of the vertex is given out here. Okay, so you will be able to find this because the equation of this is given and this has to be perpendicular, right? So find what is this distance. So this gives you breadth. Okay, you have got this equation, right? So you know that this is also 90 degrees, so that's why you will be able to find this as well. So that will be your length. Now you have founded length, you have founded breadth, multiply them, you will get your area of the rectangle. Alright, so you may refer this problem for your question number 9. So pause the video to note down. Okay, let me take question number 5. So question 5 says, if the equation of the base of an equilateral triangle is x plus y equals to 2 and the vertex is 2 comma minus 1, then find the length of the side of the triangle. So there is an equilateral triangle given to you. So this is my equilateral triangle and the equation of base is given to be x plus y equals to 2, or let me write this as minus 2 equals to 0. I am writing in general form. Now one of the vertex is given to be 2 comma minus 1. Now if I take this as 2 comma minus 1, then this 2 comma minus 1 lies on this line. So that means this equation must be satisfied. Okay, so let us see whether this is satisfied or not. So instead of x I am writing 2 and instead of y I am writing minus 1. So we have, how much is this? Is equals to minus 1. Is this turning out to be 0? No, right? So that's why 2 comma minus 1 cannot be here. Similarly, here also we cannot take 2 comma minus 1. Again, if I take, then this must lie on this line, but 2 comma minus 1 doesn't satisfy this equation. So that's why obviously that 2 comma minus 1 has to be somewhere out here. Hope this thing is clear to you. Okay, very good. So we got our vertex. Fine. Now next is, if that much is given to you, you need to find what is the length of each side. Okay, so before that, what am I going to do is, from here I am going to find what is the perpendicular distance. Okay, so we know that whenever we draw a perpendicular from one vertex in an equilateral triangle, then this perpendicular bisects this. Okay, so that's why what am I going to do here is, let me take length of each side equals to 2a. Okay, so that means this is also 2a. So if this is 2a, then this much has to be a. This much has to be a. Okay, so we'll find this. This will be a. This will be 2a. We'll use Pythagoras theorem. Okay, so let me write this as a, b, and c. Okay, so this is question number 5. So consider triangle ABC with vertex A as 2 comma minus 1 and line BC as x plus y minus 2 equals to 0. Okay, fine. Now let me draw a perpendicular AD on BC. Okay, so let AD be perpendicular to BC. Okay, so therefore let us find what is AD. So AD is the perpendicular distance, so that's why this will be equals to modulus of A x1. So how much is A? A is 1, isn't it? So the number attached to x is 1, so that's why it will be A into x1. x1 is 2 plus B is 1, so B into y1 is minus 1, yes, plus C is minus 2, so that's why we have minus 2 out here, whole divided by square root of A square. A is 1 square, B is also 1, so this much. Okay, so as we saw earlier, this turns out to be, okay, so let me directly write it out here. So this turns out to be minus 1, okay, whole divided by, this is square root of 2, so this is 1 by root 2. So see here, we got AD to be 1 by root 2. Now let's make use of right angle triangle ADC. Okay, so or let me write, let each side equals to 2A. Okay, so as I said, each side is 2A, so therefore AC will be 2A and DC will be equals to BD. Yes, so DC and BD both will be equal and they will be equals to A. Okay, so in right angled triangle ADC, okay, so in this right angle triangle ADC, we have this is 90, so side opposite to this is hypotenuse. So applying Pythagoras theorem, we have AC square is equals to AD square plus DC square. Now let us put the value. So AC is how much? AC is 2A whole square equals to AD. AD is how much? AD is, just now we got AD to be 1 by root 2. So we have 1 by root 2 square. DC is A, so it is A square. So let us find what is the value of A from here. So we have this is 4A square. This A square comes here because minus A square. So this is 1 by 2, right? So from here we get that 3A square is equals to 1 by 2. So from here A square turns out to be how much? 1 by 6. So that's why from here A turns out to be 1 by square root of 6. Okay, so we got the value of A. So therefore each side will be equals to, it is 2A, right? So we have 2 into A. A is 1 by root 6, and if you want to rationalize it, you can do that as well. So we have root 6 here. So from here we have 2 root 6. Root 6 into root 6 is 6. So this 2 gets cancelled. So we have root 6 by 3 as my answer. Okay, so you may pause the video to note down. Okay, so let me take question number 6 for you. So question 6 says, find the distance of the point 0, minus 1 from the line joining the points 1, 3 and 2, minus 6. So there is a line which joins 1, 3 and 2, it is minus 2, 6. Okay, so there's a line which joins these two, and you have to find the distance of a point, that is 0, minus 1 from this line. Okay, so basically this point is given, so we need to find what is the equation of this line. Okay, so this is question number 5. So equation, this is question number, okay, I'm sorry, this is question number 6. So equation of the line joining 1, 3 and minus 2, 6 is, so it is y minus y1. y1 is 3 equals to, okay, so this is y2 minus y, see here. So equation will be y2 minus y1, so that is 6 minus 3 whole divided by x2 minus x1, that is minus 2 minus of 1. Okay, so it is 2-point form. Remember, this is x1 y1, x2 y2. So y minus y1 equals to y2 minus y1 whole divided by x2 minus x1 into x minus x1. x1 is 1. Okay, so let's find what is the equation. So we have y minus 3. So this is 3, right? So 3 by minus 3, x minus 1. So this is minus 1, yes. So we have x minus 3 equals to minus x plus 1. Okay, so get everything out here. So this is y. So we have x plus y minus 4 equals to 0. So let me call this as equation 1. Okay, so therefore perpendicular distance of 0 comma minus 1 to 1. So we need to find what is the perpendicular distance of this to this line is, so we have d equals to ax1. So a is 1 into x1. x1 is how much? x1 is 0, right? Plus b is 1 into y1. y1 is minus 1 plus c is minus 4 whole divided by square root of a square. A square is 1 square plus b square. B square is also 1 square. So from here we get the 0, this minus 1. So minus 1 minus 4 is minus 5. So minus 5 modulus of minus 5 divided by square root of 2. So this turns out to be 5 by root 2. Okay, so my answer will be 5 by root 2. Pause the video to note down. Now let me take the last question for the day, that is question number 10. So question 10 says find the equation of two straight lines which are parallel to x plus 7y plus 2 equals to 0. Okay, so whatever is given, let me write down first. So we have the given line is x plus 7y plus 2 equals to 0. So there is a line given to you. So you need to find equation of two parallel lines. Okay, so there are two parallel lines out there. Okay, fine. Now what is happening is these two must lie at a unit distance. So unit distance means distance has to be 1. Okay, from where? From 2 comma minus 1. Okay, so point is also given. So for example, if that point, okay, so you need to find the equation of this, and if that point is lying somewhere over there, then the distance has to be 1 unit. Okay, so that distance is perpendicular distance. That's what is the question saying. Okay, so this is the given line. So let me call this as equation 1. Okay, so the line parallel to 1 will be of the form it will be of the form ax plus by plus lambda equals to 0. Let me call this as 2. Okay, now it is given that the distance of point 2 comma minus 1 to this line, okay, so this is the parallel line, no, so to this line is how much? It is 1. Okay, so the distance or this perpendicular distance of 2 comma minus 1 to 1, I'm sorry, to this 2 is 1. That is, okay, so that is d is given to be 1. And what is the formula for d? D is modulus of ax1. A is 1, x1 is how much? X1 is 2 plus by1. B is 2, y1 is minus 1 plus c. Now what is c for me? C is lambda, isn't it? Lambda by a square, square root of a square, a is 1 square plus b square is 2 square. Okay, equals to how much? This equals to 1. Hope the thing is clear to you. Distance, that is this, must be equals to 1. Now from here we will find the value of lambda. Okay, so this is 2, this is minus 2. Okay, see here carefully, this is 2, this is minus 2. So 2 and minus 2 gets cancelled, so only lambda is left. Okay, so with modulus sign. So here we have in the denominator root 5 equals to 1. So by cross multiplication we see that lambda is equals to root 5 into 1 is root 5. Okay, so since this is my modulus, okay, so if I remove modulus, then there are two values of lambda available, right? So those two are plus minus root 5. Okay, so if I take the value of lambda to be plus root 5, then from 2 we get one of the equation will be x plus 2y plus root 5 will be equals to 0. That is one of the equation. And if I take the value of lambda to be minus root 5, then another equation will be x plus 2y minus root 5 will be equals to 0. Okay, so therefore the equations of parallel lines are, okay, so you are using 2 now. Okay, so using 2 we are going to have x plus 2y plus root 5 equals to 0 and x plus 2y minus root 5 equals to 0. So these two are the parallel lines to the given line, that is equation 1. Okay, so there is a similar question, actually in fact that is the exact question in question number 2. Okay, so there are 2 questions in question number 2, so you will try them by yourself. Okay, so you may pause the video to note down. Today we will do only this much. Thank you very much.